Hi, welcome all on Jim's Orbit. We have covered till part 4 of real number, and in the last part we have covered the problems which are based on Euclid's division algorithm, where we express the SCF as a linear combination of the numbers. Fine. That is a typical problem, though they generally don't ask this in exam, but be prepared for each and every type. Yeah. Now, in this part 5, we are going to do the most important question related to the exams. They have always given this question in 4 marks. So hopefully this time also it might come in 4 marks or maybe in 3 marks, because the syllabus is quite large this time as compared to the previous years. Okay. Now in the part 5 we are doing the word problems based on SCF and LCM. Before taking up the problems, let us just understand how we will interpret whether in the which question we have to take the SCF and the LCM. So I'm telling you one easy thing to remember. Always check if it is written that there is a number which can divide other numbers. Okay, so which can divide other numbers. Now, if it can divide other numbers, it obviously means that this number will be the factor. Okay, and if it is the factor, then we will be finding the highest common factor. Like 99% of time, there is one corner case when that is the SCF, but that is found in some different way. Okay, this number, if it is like, if suppose the answer, if you just think of the by reading the question, if you think the answer is going to be a very small number than the given numbers, then obviously you are going to find the SCF, because SCF is smaller than the numbers. Okay, this is a very important trick, smaller than the given numbers. Now suppose this is not the case. The second case can be, it can be like we have a number which is like a multiple of the given number, which is a multiple of the given number. Given numbers. So in this case, we are going to find the LCM. Now the LCM, how we will know? Again, read the question. If you think like that the question is asking for such a value which is going to be more than the given values, then obviously you are going to find the LCM. Okay, keep this in mind, and now we are going to do some practice problems based on this. Okay, these two concepts. So let us read the question number 1. It says 144 cartons of Coke cans and 90 cartons of Pepsi cans are to be stacked in a canteen. Now you are going to stack something. Okay, so you have 144 of Coke cans and 90 of Pepsi. Okay, so understand now. Next line is, if each stack is of the same height and is to contain cartons of the same drink, they have to contain cartons of the same drink and they have to be of the same height. Same height means they have to be in the same number. Okay, so if suppose you are going to place one onto the other on top of another like this. Okay, so yeah, we can continue like this. Is it like, can we divide, see a number which is going to divide this also, because you are going to place in such a way that 144 can be placed in this stack form. Also it is like this, 90 should also be placed in the stack form. So there is a number which has to divide this and this. Now come back again, what I just told you in the first step, which can divide other numbers. So what we are going to find then? The SCF, direct. So let us come back. It can divide both the numbers, hence we are going to find the SCF of the two numbers. Okay, so you are going to stack in such a way that each of these stacks should have the same number of the cans, and also they have to be of the same, like either they will be of all Coke or all Pepsi, like Coke and Pepsi do not mix. Okay, so you are going to find the SCF of 144 and 90. Now we know how to find the SCF. Okay, we have already covered this when we were doing the part 1 and part 2, how to find the SCF. So 90 and 144. This will be 91 times 90. So 54. We will move ahead. 54 2 times will be quite a large value. So just 1 times. This will be 6 and 3. Now 54 36, 1 times 36, 18, and this is 36. So 18 2 times this. So we have got 18. Now the SCF of this is 18. Hence, if you notice also that 18 also divides 144, correct? So 18 8 is 144, and 18 also divides 90. 18 5 is 90. Hence, we will be able to like place each car, like each coke will be like 18 18 18. Every will be 18. Now if the question has asked this, what would be the greatest number of the cartons each stack would have? Like how many stacks you can, how many cartons you can put in each stack? In each stack you have noticed now you can put that much value, so 18. Okay, so the answer to this is 18. Now suppose they have also asked how many like stacks you will have. The question was also how many stacks we could have. Stacks. Now how many stacks? Now remember this 144, we are going to divide in 18 cartons each. So every will have 18 cartons each. Okay, so 18 cartons. So this is the total stack out of the Coke cans plus the stack from the Pepsi cans. So 90 by 18. This is 8 plus 5, hence 13 stacks altogether. This is the answer for this, while this is the answer for the greatest number of the cartons. You could have also added both these values and then divided by 18. That would have given the same answer. Okay, that's just a mathematical process, nothing else. I hope you have understood this. So let us take the next part. Okay, question 2 says 3 bells toll at interval. Toll means like they all ring at the same time. Okay, so 3 bells toll at intervals of 9, 12 and 15. So toll means ringing. Okay, ringing at intervals of 9, 12 and 15 minutes respectively. If they start tolling together at 10 a.m. If they start together at 10 a.m. So first they have tolled together at 10 a.m. What will be the next toll? Obviously, can you say that there is a number which divides this and then they will toll? It's like 3 will divide 3, 4 and 5. So 3 times, 4 times, 5 times. Will they ever toll at 3, 10, 3? How can they toll at 10, 3 if the next will be going after 9 minutes only? Correct? So it's impossible that you will be taking SCF in this. Yeah. So you'll be taking such a value which can be like the multiple of this and this, so that they both divide that number. So these have to divide this. Hence, this should be the LCM of them, the least value. Okay, we have to find the first time they will toll together, not the like after times. There will be like multiple times they will toll together, but in this question they have asked the first time they will toll together. Okay, hence we are going to find the LCM. The answer is the larger value, so we are going to find the LCM. I hope you have understood this now. Okay, so the LCM of 9, 12 and 15 we have already covered. Again I am telling you this. So 9, 12 and 15 we have 3, 4 and 5. I could have started with 2. Okay, it's not an issue right now. So these all are prime numbers, so we will just write them and then skip out this. Okay, so 3 and 5. Okay, we have covered this. So the LCM is directly we can multiply the numbers 3 into 2 into 2 into 3 into 5. I made a mistake somehow. I should have started with 2, but that's not change anything. This is the fundamental theorem of like arithmetic. Yeah, so you can actually swap these prime factorization because it is unique. The order of the prime factors can be interchanged. This is only fundamental theorem of arithmetic. I have not covered it. We have to multiply 5 and 2 all together. Okay, so 5 and 2 you have to multiply. So because this will give us 10 now. So this will be 3 2s are 6, 6 3s are 18. Now 1 8 and 0. So 180 minute. Fine. So 180 minute is the common time after which they will toll together. Now 180 minute is how many hours? It is 3 hours. Hence, if they have tolled together at 10, the next time they will toll together will be 3 hours after 10. So that will be 10 plus 3, 13 hours. 13 hours in normal AM and PM format is 1 PM. Okay, so the next time they will toll together is at 10 plus 3 hours. Okay, this is I'm writing in 24 hours format. So 13 hours, which is 1 p.m. Fine, this is our answer. I hope you have understood this. So let us take the next problem. Okay, now question number 3, again we start reading it. An army contingent, so there is an army group of 140 members, is to march behind an army band, which is another band of another group, an army band of 96 members in a parade. So you have one group where you have 140 members, that is the contingent of army, while the other band of army has 96 members. The two groups are to march in the same number of columns. Again, you have to make them such a way that they have the same number of columns. You cannot change the number of columns. So what is the maximum number of columns in which they can march? Obviously, you will never be finding the LCM in this, because LCM will be more than these two values, correct? And how can you put number of columns like more than the number of people, correct? So in order to get the number which can exactly divide this also, so it can make the column of this and it can also divide this, a number which can divide both of them is what? The SCF. Also the answer should have been the value which is lesser than these two values. So again we will find the SCF. If you're finding the less value, the answer is SCF. If you're going to find the more value, the answer is LCM. So less value, HCF. SCF of 140 and 96. So we are going to find the SCF of these two numbers. Okay. 1 times will work. Now this 2 times will work. 2 4s are 8, 2 4s are 8. So 88 will come here. Okay. Now this will be 44. So 8 5s are 40. So 4 will come and this will be 8. So 4 2s are 8. Okay. So we have found that the SCF of these two numbers is 4. Now it's written the two groups are to march in the same number of columns, and previously they have said that they will be marching behind. So like this we have two groups that are marching behind, but they have to march in the same number of columns. So like number of columns will be same, whatever they will be, like they will be same. Okay, but we don't know how many columns were there. Now we see that we have found the SCF is 4. It implies that 4 can actually divide this completely and it can also divide this completely. If it can divide both of them completely, then obviously we will have like this 4 dividing this, we will have this 35, 35. 4 3s are 12, 4 5s are 20. Okay, so 35 people in each of these columns. We will have 4 columns, correct? And also 4 columns will be of 96 members. This, okay. So and in each column there will be 24 persons. Like this they will be arranged. Okay. So we will have, what is the maximum columns we can put them so that they can march? It will be 4 columns. This is a very important problem, and generally the units are also same. This is also correct. Now we are saying that they are having 4 columns. Okay. Fine. I hope you have understood this. So let us take the next question. Question 4 says, Rahul, Anjali and Sanya start preparing cards for all the persons of an old age home. In order to complete one card, they take 10, 16 and 20 minutes respectively. Okay, some 3 persons are there who are actually preparing cards, and they individually take 10 minutes, 16 minutes and 20 minutes. Okay, if all of them started together, after how much time will they start preparing a new card together? Which values do these children reflect? So it's a value based question. They always ask this in 4 marks. So 3 marks are for this part, 1 mark is for value answering. Correct value, you have to just mention a word, correct? Okay. Now we can easily see that this is the same kind of question we have did like in the question 2, where we have used the bell concept. Again, the answer will be more than these values, because they will be preparing after a card after some time, not in just few minutes between this. Hence we are going to find the LCM. I hope you have understood direct now what we are actually doing. Okay, so we have got the trick. We are going to apply it. So 10, 16, 20. Let us find the LCM. 2 times 5, 8, 10. Again 2 times. Okay, this is 4, 5. Again 2 times. I have to actually move till I get a 1 and there is no 2 factor left. Okay, so this is okay. Now 5 will work. So 5, 1, 5. Now just multiply these, we will get the LCM. This will be 2, 2, 2, 2 into 5. That will be, this 5 into 2 becomes 10. So 2 to 4, 4 to the 8. 8 times 10 is 80. So after 80 minutes. So after how much time? After 80 minutes. I just told you the answer is always the same unit as the question. So this is minutes. So this should be minutes. So after 80 minutes. Fine. Now, which values do these children reflect? Let us read the problem again. They were preparing the cars for an old age home. Okay, so this seems to be caring or like motivated to help old age people. Correct. So they are caring for the old age persons. So they are preparing cars for the old age people. So they feel motivated to help old age people. They are self-motivated. They are drawing cards. They are making cars for them, or they are showing care, or they are showing affection or love towards the old age people. Okay, whatever you write, they all are the same. You have just have to one correct mention, one correct word. Okay, let us take the last problem now. I hope that so far you have understood how we are dealing with this. So this is the last problem, and you just read the question and try to understand before I tell you this. Okay. Okay, let's begin now. So in a seminar on the topic Liberty and Equality, the number of participants in Hindi, Social Science and English are 60, 84 and 108 respectively. Find the minimum number of rooms required if in each room same number of participants are to be seated and all of them being in the same subject. It's like there is a seminar going on a particular topic and some persons there are some participants, they are on individually Hindi, Social Science and English. Okay, each of them have different participants. We have to find the minimum number of rooms required if in each room same number of participants. Again, you have to put the same number, so you have to take a number which can divide this and this, and that is the SCF. So much easy it's now to judge. Okay, 60, 84, 108, you have to find this SCF. Okay, how to find the SCF of three numbers? You can also do the prime factorization of each of them separately and take the common, or you can apply the long division twice. So first you can select one pair and the answer what you get, you have to apply it to the third number. So I'm going to do the long division only. You can apply any method. So 61 times 60, 4, 2, 24, 2 times 48, so 2, 12. So this will be 12, 2 times 24. This will give us 0. Now we have going to find the SCF. Now in this question we have found the SCF is equal to 12. Now because the SCF is not the final answer this time, because there is one more number left, we are going to take that number and the third number and let us find the SCF of these two. This is very easy. 12 9 times is 108. So you can directly say that this 12 was also the SCF of the third part. So SCF is directly 12. So this is the SCF, final SCF. This is the initial SCF of the two numbers. It's not the final SCF. Okay. Now if the SCF is 12, you have to now find same number of participants. You have to find the number of rooms. So I just told you that whatever you find the SCF, that has the same unit. Now these participant units was this. So these were the people. These were not the rooms. Okay. Now SCF is 12 means there will be 12 person in each room. 12 participant in each room. Hence, what we are going to do, we are going to just take the total participants and divide by the number of participants we can put in one room, and hence we will get the number of rooms directly. So we will add all this and we have to divide by 12. This will give us 4, 8, 12, 1, 7, 8, 15, 5, 1 and 2. So this will be 12. So 12 2 times 24, then again 1, so 12, 1. Hence we will get 21 rooms. So the minimum number of rooms you will require in order to put same number of participants in each room to make them seated there, you need at least 2 rooms. Okay. You can get more than this also, but 21 is the least requirement. I hope you have understood this. So we have covered this thing. We have found how to do the problems based on SCF and LCM. These were very simple problems, but yeah, these are the only problems they have asked so far. So they don't ask very typical problem. Okay, they ask very simple problems in this chapter, in the word problems. So you just practice it from your book, and if you have any doubt, you can post them in the comment box, and I'll try to answer that then there. Otherwise, I'll try to make a separate video on it. I hope you have liked the content. If you have not liked it, do not forget to press the dislike button and tell me in the comment box what I should do to improve it further. Okay, see you in the next video. Thanks for watching.